Hello, this is question number 5.3. In this question, I have to design 3-bit wide synchronous moderate up counter using 3 flip-flops. So, I'll be using this model. This is a 4-bit wide, so I'll be using till 3 T flip-flops. As you can see, the inputs of the second T flip-flop is the Q of the first T flip-flop, and the input of T of the third flip-flop will be the AND of the Q0 and Q1. And you can see this is the clock is provided. Clock is same for all the three T flip-flops. So this is synchronous in design. So let us see the code. So in this code, as you saw in the explanation, we had three T flip-flops. So it is defined over here. For every T equal to 1, the output will be toggled. This is the design. And if you remember that the first toggle was fixed to 1, second was the Q of the first T flip-flop, the third toggle was the Q of the first and the second ANDed. And finally, I'm giving this temporary output, connecting this temporary output to Q. So if you see here, the clocks and Qs are the input. Now this is the test bench. This is here is the component declaration with clock and Q as the input and the output respectively, same as the entity. And these are the signal declarations and component instantiation. And finally, I have done a clock not equal to not clock after each 10 nanosecond. Now let us simulate and visualize this. So I'll compile and simulate it. So you can see we have made a synchronous up counter. Here it is starting with 000, then it is going to 001, then 2, then 3, then 4, then 5, then 6, then 7, and again to 0. So we have made the 3-bit synchronous up counter using T flip-flops. Thank you.